Hello, I hope each and everybody out there are doing great and having good health. In this video, from the title or thumbnails, you know that it's about naming of alkane, and I hope that students of English versions and any other is watching right now, you know that I have started a long video series of organic chemistry, started from vital force theory, and this is the 6th lecture where I shall explain the naming process of alkanes. Basically alkanes, and then after I'll definitely explain about alkene, alkyne, aldehyde, fatty acid, and each and every single functional group. You know that I have already uploaded a video on functional group, so sequentially I'm going at. So think about it, naming of alkane, we know that this is actually a systematic process that has been designed back in 1892. Back in 1892, Geneva, Switzerland, there was a conferences with all sort of chemists, and they developed some naming process, or they developed a system to name this sort of aliphatic or aromatic hydrocarbons or organic compounds. And then a lot of after conferences going on, 1993, they developed a process which is called IUPAC, you know it, this is International Union for Pure and Applied Chemistry, and this is called Geneva process or Geneva system. So according to IUPAC system, if you want to know that each of every single compounds, there will have 3 different part of its naming. That is number one, prefix. There will be a prefix, and then secondly there will be word root, and thirdly there will be suffix. Okay, so what is the meaning of prefix, word root and suffix? In this video I shall try to explain all these things, but I hope you know that name of organic compounds, or basically alkane in this video, depends on specifically the number of carbons. We have to look first the number of carbons of that compounds. So if there is single carbon, then it's called meth. 2 carbon, eth. I hope you know that this is the Greek alphabetic order, that is meth, eth, prop, but, pent, hex, hept, oct, non-dec, and then after undec, dodec, tridec. If you go for carbon 20, it would be icosane, and then 21 for henicosane. So like that. But I hope there will be not more than carbon 12, because we will practice every single functional group like alkane, alkene, aldehyde, fatty acid, ketone, ether, amide, like this. So this one is our main thing, word root. Okay, and prefix and suffix is coming after. So I hope you know that the first member of alkane is what? The first member of alkane is methyl. We know that carbon, it has 4 valence electron, 4 valence electron, that is tetravalent. So carbon is tetravalent. So every time whenever we will write something like this, the other part should be hydrogen, or even any elements which has 1 valence electron like chlorine, even fluorine, or even any halogens. So if there is nothing around carbon, that is hydrogen. So usually we know that hydrogen 1 valence electron, so carbon is surrounded by 4 hydrogen, and that is methane. So if we know that there is another carbon like this, 1, 2, 3, 4, 5. Suppose there is 5 carbon, and all these bonds are sigma bond. You know that sigma bond. So the other side, what will happen? 1, 2, 3. It has 4 valence electron. It has 1, 2. So this is 3, 4. 1, 2, 3, 4, 3, 4, 3, 4. So if we arranged every time that there is hydrogen in each aspect, then what is the name of alkane? Now you see there is 5 carbon. There is no more carbon, and this is a very single and nothing is attached here. So this is simply pentane. So this pent is word root. So there is 5 carbon, so we say this is pent, and as there is no double bond or triple bond, all are single bond, so after that we will say this is N, because in case of naming of alkane, the suffix would be simply N. In case of alkene, the suffix would be in. In case of alkyne, it would be ein. But as this class is about naming of alkane, definitely A and E suffix would be added after the word root, and word root is that which will be determined by the number of carbon present in that compound. So it has 5 carbon, so I say this is pentane. And now what more interesting thing is coming on. In case of naming alkane, we must consider one thing, that is substituent, and that is about prefix. In this case, you can say this is substituent, or you can say this is branch. So in case of naming of alkane, now the interesting part is coming on, that when we will consider about branch or substituent, we need to think about alkyl group. What is alkyl group? Alkyl group, I hope you have heard about it, alkyl group, that is alkyl, it means alkyl group that alkane, if you remove one hydrogen from alkane, then it will be corresponding alkyl. Suppose CH4 is methane, so if you just remove one hydrogen, it will be CH3, that is methyl. And if there is CH2CH3, which is actually C2H5, this is ethyl. And when there is 3 carbon, like CH2, CH2, CH3, so now you know this is actually propyl. So we need to think about propyl when there is 3 carbon alkyl. So this is called alkyl group, which can be added with the alkanes as substituent or branch. And hence the interesting thing will come. Suppose we know that the general formula of alkane is what? CnH2n plus 2. But this is not right in case of cycloalkane. I'll come up with cycloalkane after this. But before going to explain, CnH2n plus 2 is the general formula of alkane. So now if you have 10 carbon, then hydrogen would be 2 times 10 is 20. 20 plus 2 is 22, which is the formula of decane. So this is actually decane. And if you have like C17, 17 carbon, so hydrogen number would be 17 times 2 is 34. So hydrogen is 36. And as you have 17 carbon in your alkane compounds, then it would be heptadecane. That is heptadecane. This is very easy. I mean, if you go for C7, then H should be 16. If you go for C9, H should be 20, which is normal. I mean, N to N plus 2. So this is heptane and this is nonane. Here is decane, here is heptadecane. So you can go for like methane, ethane, propane, butane, pentane, hexane, heptane simply. But when there is branch or substituent, we need to be careful. Think about it, okay? So as we are going to study right now substituent, think about the alkyl group. So alkyl means what? When you remove one hydrogen from alkane, it is alkyl. So some name of alkyl, that is methyl, ethyl, propyl, butyl and pentyl. Okay. So according to IUPAC system, what we know that first there will be branches or substituent as prefix, and then we have to think about the number of carbon is given, which is word root, and then after we will consider according to the functional group, either it is N, in, ine or aldehyde, fatty acid, whatever, that is suffix. So three things: what? Prefix 1, word root 2 and suffix 3. Let's start. Think about it. 1, 2, 3, 4. Okay? Now there is a branch, another carbon. So what should be the full divisions of this? I think there should be 3 hydrogen, 1 hydrogen, 2 hydrogen, 3 hydrogen and 3 hydrogen. Now you think this methyl is added to which number carbon? Now you need to count the number of carbons. From where? That is, you must know one thing is lowest sum model. Lowest sum model. What is this? Lowest sum model is that we have to count the branch number of carbon from any side where it should be in the lowest position. Suppose if we start counting from this side 1, 2, 3 and 4, then this methyl group is placed in number 3 carbon according to my previous counting process. But if I start from here, that is 1, 2, 3 and 4, simply we can see that this methyl group is placed in number 2 carbon. So as this is the lowest, then the naming would be, we know this is 4 carbon, so there is no double bond, this is alkane, so simply this is butane. So prefix would be 2 hyphen methyl, and no space after. 4 carbon, that is but, and then there is all single bond, so this is suffix. Now you think 2-methyl is the prefix, but is the word root and N is the suffix. And according to IUPAC system, this is the process, this is the right naming of this aliphatic hydrocarbon. So it would be 2-methyl-butane. I'm just starting from the very the primary level. Alkane naming is a bigger thing. I'll come up with the second part of this video. That before going to explain the bigger part, let's fix this. 2-methyl-butane. Okay, 2-methyl-butane. Think about other side. Suppose 1, 2, 3, 4, 5, 6. Now we got 6 carbon and there is no single bond. So first we can see this is hexane. Hexane. But what else? If there is C and then C. Now we got 2 branches or 2 substituent. There was 1 substituent. Here is 2 substituent. Now you see, you have to count the largest or the maximum carbon numbers from any side. You must find the maximum carbon numbers. So if I give another carbon here, now it's getting more interesting. Now you see that from which part if you go, you'll find the maximum carbon. You see 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, 7. So if I go from this way to this way, we will find 7 carbons. And again, if you come from this way to this way, we'll again find 7 carbons. Right now, the name is heptane. but we have branches. We need to count the number of branches on these carbon. Now you think, if we start 1, 2, 3, so there is a branch in number 3 carbon, 4, 5, 5, same 5 number carbon, so there is 3 and 5. If you go from this way, 1, 2, 3, again this is 3, 4, 5, again 5. So it doesn't actually vary. If we count from this way to this way, the substituent will be in 3 and 5 number position, and if we go from this way to this way, this will be similar like 3 and 5 number carbons. So according to this process, we can see that this is CH3, CH2, CH, CH2, CH, CH2, CH3, and this is CH3 and CH3, as because this is methyl group. Now we know that 1, 2, 3, 4, 5, 6, 7. So the name of this compound would be 3 and 5. So 2-dimethyl. So 2-methyl group is added. So that is why when we count the number of branches, we must think that if there is single methyl, then it will be mono, or we should say that 2 is for di, and when there is 3 would be tri, 4 tetra. So as there is 2 methyl, I mean 2 different methyl is added into different carbons, then the name would be 3, comma, you put comma and then 5, okay, hyphen, and then 2-methyl. So that is dimethyl. The number of carbon is 7. So the word root is hex, and then is all our single bond. It would be N. So the name of this compound would be 3, 5 dimethyl hexane. Okay, I'm just in a primary mode. If anybody of you those are watching right now, if you feel any sort of trouble, please think this is a primary level naming process of alkane. So simply we can go for methane, ethane, propane, butane. Actually in SSC level, those are watching right now, even Cadet college students from SSC level, if you see, this should not be complex actually, but according to syllabus we have no use of it. But when you go to HSC level or A level, this definitely is the primary level. So I think we should go in the next level. Now one more thing I should mention, that line model. What is line model? So usually how you express this 1, 2, 3, 4, 5, 6. Okay. There is 2 and there is 1. Suppose this is the compounds and the other side is occupied with hydrogen. Now let's think, there is methyl group, there is also methyl group, there is also methyl group, and this is CH3, there should be nothing, CH2, CH, CH2, CH3. What should be the name of this compound? Now you think, if you go from this side, 1, 2, 3, branch, we need to find the maximum carbon number. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Anyhow, we will not find 7 carbons, we will find always 6 carbon. But we find the longest part, that is, this is the longest chain. Okay, this is the longest chain. And we got 6 carbon. So the word root is hex. Now we need to find, of course we got suffix also, this is N. So this is hexane. But the branch, we have 1, 2 and 3 branch. In which carbon? If we start from here, 1, 2, 3, 4, 5, 6. So we have 3 branch. If we start from here, 1, 2, 3, 4, 5, 6. So we have 3, we have 5 and 5. So if we add, then it is 13. But if we start from the right side, reversibly, if we start from the right side like this, that 1, 2, 3, 4, 5 and 6. So the branch would be in 2 plus 2 plus 4. Now you see this is 8. Concentrate. If we start from here, 1, 2, 3, 4, 5, 6, the branch would be in 3, 5 and 5 position, and the sum model is 13. So the lowest sum model is that we need to count carbon number and need to find the largest carbon chain based on the branch or substituent should be in the lowest carbon, and that is called the lowest sum model. So if we start from here in this side, 1, 2, 3, 4, 5, 6, so the second carbon is occupied with 2 branch, 2 methyl. So 2 plus 2, and number 4 carbon is occupied with another branch. So together this is 8. So that should be my choice. So I need to count the carbon from the right to left, not left to right. So from right to left, if we go, the name of this compound should be 2, 2, 4. 2, 2, 4, okay, hyphen, 3 methyl, I mean that should be trimethyl hexane. So now you see, according to the IUPAC system, you have a very long prefix, you have word root, and you have suffix. So prefix is what? Branches or substituent. We are counting the branches and substituent based on what? Based on the numbering system. What is the numbering system? Firstly, we need to find the longest carbon chain, and the way of finding longest carbon chain is we need to find from right to left and left to right. Anyway, what would happen if I just show you another thing, that we also can express this in this way. Suppose there is 6 carbon, okay? 1, 2, 3, 4, 5, 6. There is another way to express this aliphatic hydrocarbon. See these dots, every dot is actually representing 1 carbon. So you have 6 carbon, so you have got 6 dot. So 1, 2, 3, 4, 5, 6. Now in 5, so 1, 2, 3, 4, 5, 6. So we have to remove it because we counted from right to left. So it should be 1, 2, 3, 4, 5, 6. Now in number 2 carbon there is 2 methyl. So this is like that. This is another dot which is expressing methyl, and in 4 there is another dot. This is also the expression of this compound. Whatever we say that butane, it should be like this. 1, 2, 3, 4. When there is hexane or there is octane, 1, 2, suppose this is 1, 2, 3, 4, 5, 6, 7, 8. So this expression, it's called octane, simply N-octane. So you understand what is lowest sum model, what is prefix, what is suffix, and what is word root. Word root is always depending on the number of carbon we have. So I'm just giving you a simple idea about the naming of alkane. Or even you also can find, suppose it's given 2, 2, dimethyl 4-ethyl heptane. Suppose the name is given. So from this way you also can find the structure of the compounds. So you've got 2 and 2 dimethyl, so 2-methyl. So as you have heptane, so you're sure there are 7 carbons. So 1, 2, 3, 4, 5, 6, 7. And if I count from this way, that should be number 2. In this carbon there are 2 dimethyl. So there is 1 and 2. And number 4, there is ethyl. So it should be like this. And this is the structure of 2, 2 dimethyl 4-ethyl heptane. So if I go for like CH3, 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 CH2, 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 CH3, CH2, CH2, CH3. And if I can express this in a ball stick way, then that should be 1, 2, 3, 4, 5, 6, 7. In number 2, there is 1, 2, 3, 4. There is another, and this is 2, 2 dimethyl 4-ethyl. Sorry, that should be like another, because there is 2 carbon. 4-ethyl heptane. Same thing. So I hope you understand. Actually, I tried to make it short also, because I can go for hours and hours also naming this alkane. But I hope those are watching right now, you should practice. You should practice by naming this, and this is actually easy. So what type of questions can rise on your exam paper, that is not sure, but I hope you know everything is touched. So according to the IUPAC system, what you need to consider first? Number 1, the rules. Rules is number 1. What? Find the longest. Find the longest carbon chain. Okay? Find the longest carbon chain. The secondly is that numbering this longest carbon chain based on what? Based on the substituent. Numbering based on substituent in lowest sum model. Lowest sum model. What is lowest sum model? So when there is more than one branch or substituent, we have to find the lowest sum model, where we can find from right to left or left to right to make it lowest the number of branch. So simply these two things we can remember, and what to find next is the word root plus the appropriate functional group. When there is single bond, if there is a single double bond there, that should be alkene. But in case of cycloalkane, that I actually said it the first time, that in case of cycloalkane, the naming would be a little bit different. What is cycloalkane? So these were actually open chained, but when there is closed chain hydrocarbon, you know, these are called cycloalkanes. And the general formula of cycloalkane is like alkene, that is CnH2n. What? Yes. If you find this is simply cyclopropane. Why? This single bond, this single dot is expressing carbon. So like this, 1, 2, 3. So there is 2 hydrogen, 2 hydrogen and 2 hydrogen. According to the open chain process, what had been, the general formula for alkane was CnH2n plus 2. So if there is C3, then hydrogen should be 8. That is called propane. But when there is cyclopropane, carbon is 3 but hydrogen is 6. When there is cyclobutane, it's like this. There is 1, 2, 3, 4. And every time there is 2 carbon attached with each carbon. That is C4H8. This is called cyclobutane. So we say this is cyclopropane and this is cyclobutane. So if you go for fifth like this, that should be cyclopentane. If it goes like this, then it should be cyclohexane. It should be cyclohexane. So according to the cycloalkane process, what should be? I mean, we'll just count the number of carbon. And in a closed chain process, if there is 3 carbon, cyclopropane, 4 carbon, cyclobutane, 5 carbon, cyclopentane, 6 carbon, cyclohexane. And if there is a substituent in this cycloalkane, what would be the naming of this? Very simple, very simple. In case of naming cycloalkane, suppose there is cyclohexane and here CH3. So simply we can say that CH3 is, we can name it like 1, 2, 3, 4, 5, 6. Cyclohexane, but methyl branch or substituent is added here. So we can say this is 1 methyl cyclohexane. And if there is another substituent here, suppose forget the naming, if there is another substituent here with these, suppose CH2, CH3. Now you see there is ethyl group and there is methyl group. In this two name, according to the alphabetic order, E is the first, then M. So according to this, we need to find this one, 1, 2, 3, 4, 5, 6. In this case, the name would be 1-ethyl, 3-methyl cyclohexane. And this is the name of cyclohexane if there is alternative branches. So this is a very short discussion about naming of alkane. I hope those are right now is watching. After this video, if you find anything important or if you find anything to let me know, please do not hesitate to comment in the comment section. And I'm trying my level best to upload some good things in front of you. So take care, stay well, see you on alkenes and alkynes naming.